Part 2 of Pi Network's Pi white paper, which is the validation and everything that encompasses what Pi Network is about as it relates to their cryptocurrency. Part 2 will be stating the problem, cryptocurrencies, as well as the solution, which is known as Pi. Mining goes mobile. Let's dive in. The problem is centralization of power and money. Let me clear this up. Apologies real quick. There we go. Centralization of power and money put first. Generation cryptocurrencies out of reach. In the early days of Bitcoin, when only a few people were working to validate transaction and mining the first blocks, anyone could earn 50 Bitcoin by simply running Bitcoin mining software on their personal computer. As the currency began to gain in popularity, clever miners realized that they could earn more if they had more than one computer working to mine. As Bitcoin continued to increase in value, entire companies began to spring up to mine. These companies developed specialized chips and constructed huge forms of servers using the ASIC chips to mine Bitcoin. The emergence of these enormous mining corporations drove the Bitcoin gold rush, making it very difficult for everyday people to contribute to the network and get rewarded. Their efforts also began consuming increasingly large amounts of computing energy, contributing to mounting environmental issues around the world. The ease of mining Bitcoin and the subsequent rise of Bitcoin mining farms quickly produced a massive centralization of production power and wealth in Bitcoin's network. To provide some context, 87% of all Bitcoins are now owned by 1% of their network. Many of these coins were mined virtually free in the early days. As another example, Bitmain, one of Bitcoin's biggest mining operations, has earned billions in revenue and profits. The centralization of power in Bitcoin's network makes it very difficult and expensive for the average person. If you want to acquire Bitcoin, your easiest options are to mine it yourself. Just hook up the specialized hardware. Here's a rig on Amazon if you're interested, and go to town. Just know that since you'll be computing against massive server farms from across the world, consuming as much energy as the country of Switzerland, you won't be able to mine much. Buy Bitcoin on an exchange today. You can buy Bitcoin at a unit price of $3,500, over $62,000 currently at the time of the writing. Note, you can buy a fractional amount of Bitcoin. Of course, you would also be taking a substantial risk in doing so, as the price of Bitcoin is quite volatile. Bitcoin was the first to show how cryptocurrency could disrupt the current financial model, giving people the ability to make transactions without having a third party in the way. The increase in freedom, flexibility, and privacy continues to drive the inevitable march towards digital currency as a new norm. Despite its benefits, Bitcoin, likely unintended, concentration of money and power present a meaningful barrier to mainstream adoption. As Pi's core team has conducted research to try to understand why people are reluctant to enter the cryptocurrency space, people consistently cited the risk of investing mining as a key barrier to entry. Investing/mining as a key barrier to entry. Solution, Pi, enabling mining on mobile phones. So that's what the Pi Network brought to the table. After identifying these key barriers to adoption, the Pi core team set out to find a way that would allow everyday people to mine or earn cryptocurrency reward for validating transactions on a distributed record of transactions. As a refresher, one of the major challenges that arises with maintaining a distributed record of transaction is ensuring that updates to this open record are not fraudulent. While Bitcoin's process for updating its record is proven, burning energy, money to prove trustworthy, it is not very user or planet friendly. For Pi, we introduced the additional design requirement of employing the consensus algorithm that would also be extremely user friendly and ideally enable mining on personal computers and mobile phones. In comparing existing consensus algorithms, the process that records transactions into a distributed ledger, the Stellar Consensus Protocol, emerges as the leading candidate to enable user-friendly mobile-first mining Stellar Consensus Protocol was architected by David Maziers, a professor of computer science at Stanford, who also serves as chief scientist at the Stellar Development Foundation. SCP uses a novel mechanism called Federated Byzantine Agreements to ensure that updates to a distributed ledger are accurate and trustworthy. SCP is also deployed in practice through Stellar Blockchain that has been operating since 2015. A simplified introduction to consensus algorithms. Before jumping into introducing pi consensus algorithms, it helps to have a simple explanation on what a consensus algorithm does for a blockchain and the types of consensus algorithms that today's blockchain protocols generally use. Bitcoin and SCP. This section is explicitly written in an oversimplified manner for the sake of clarity and is not complete. For higher accuracy, see the section Adaptations to SCPs below and read the Stellar Consensus Protocol paper. A blockchain is a fault-tolerant distributed system that aims to totally order a list of blocks of transactions. Fault-tolerant distributed systems is an area of computer science that has been studied for many decades. They are called the distributed systems because they do not have a centralized server, but instead they are composed of a decentralized list of computers called nodes or peers that need to come to a consensus as to what it is content or as to what is the content and total ordering of blocks. They are also called a fault tolerant because they can tolerate a certain degree of faulty nodes into the system, e.g. up to 33% of nodes can be faulty and the overall system continues to operate normally. There are two broad categories of consensus algorithms: the one that elect a node as the leader who produces the next block, and the ones where there is no explicit leader, but all nodes come to a consensus of what the next block is after exchanging votes by sending computer messages to each other. Strictly speaking, the last sentence contains multiple inaccuracies, but it helps us explain the broad strokes. Bitcoin uses the first type of consensus algorithm. All Bitcoin nodes are competed against each other in solving the cryptographic puzzle. Because the solution is found randomly, essentially the node that finds the solution first by chance is elected the leader of the round who produces the next block. This algorithm is called proof of work and results in a lot of energy consumption. A simplified introduction to Stellar Consensus Protocol. Pi uses the other type of consensus algorithm and is based on Stellar Consensus Protocol, which is the SCP, and an algorithm called Federated FBA. Such algorithms don't have energy waste, but they require exchange of many networks messages in order for nodes to come to consensus on what the next block should be. Each node can independently determine if a transaction is valid or not, e.g. authority of making the transition and doubling spending based on the cryptographic signature and the transaction history. However, for a network of computers to agree on which transactions to record in a block and the order of these transactions and blocks, they need to message each other and have multiple rounds of voting to come to consensus. Intuitively, such messages from different computers in the network about which block is the next would look like the following. I propose we all vote for block A to be next. I vote for block A to be the next block. I confirm that the majority of the nodes I trust also voted for block A, from which the consensus algorithm enables this node to conclude that A is the next block, and there could be no block other than A as the next block. Even though the above voting steps seem a lot, the internet is adequately fast and these messages are lightweight. Thus, such consensus algorithms are more lightweight than Bitcoin proof of work. One major representative of such algorithm is the BFT. Several of the top blockchains today are based on variants of BFT such as NEO and Ripple. One major criticism of BFT is that it has a centralized point. Because voting is involved, the set of nodes participating in the voting quorum are centrally determined by the creator of the system in its beginning. The contribution of FBA is that instead of having one centrally determined quorum, each node sets their own quorum slices, which will in turn form different quorums. New nodes can join the network in a decentralized way. They declare the nodes that they trust and convince other nodes to trust them, but they don't have to convince any central authority. SCP is one instantation of FBA. Instead of burning energy like in Bitcoin's proof of work consensus algorithm, SCP nodes secure the shared record by vouching for other nodes in the network as trustworthy. Each node in the network builds a quorum slice consisting of other nodes in the network that they deem to be trustworthy. Quorums are formed based on its members' quorum slices, and a validator will only accept new transactions if and only if a proportion of nodes in their quorum will also accept the transaction. As validators across the network construct their quorums, these quorums help nodes to reach consensus about transactions with guarantee on security. You can learn more about the Stellar Consensus Protocol by checking out this technical summary of PCP. All right, so I'm going to proceed here, and then we'll ease into the next part. Pi's adaptation to Stellar Consensus Protocol, SCP. Pi's consensus algorithm builds SCP has formally proven and is currently implemented with the Stellar Network. Unlike Stellar Network consisting of mostly companies and intuitions as nodes, Pi intends to allow devices of individuals to contribute on a protocol level and get rewarded, including mobile phones, laptops, computers. Below is an introduction of how Pi applies SCP, enabling mining by individuals. There are 4 roles Pi users can play as Pi miners, namely pioneer, contributor, ambassador, node. A pioneer, a user of the Pi mobile app who is simply confirming that they are not a robot on a daily basis. This user validates their presence every time they sign into the app. They can also open the app to request transactions, make payment in Pi to another pioneer. Contributor, as a user of Pi mobile app who is contributing by providing a list of pioneers he or she knows and trusts, in aggregate, Pi contributors will build a global trust graph. Ambassador, a user of the Pi mobile app who is introducing other users into Pi network. Node, a user who is a pioneer, a contributor, using the Pi mobile app and is also running the Pi node software on their desktop or laptop. The Pi node software is the software that runs the core SCP algorithm, taking into account the trust graph information provided by the contributors. A user can play more than one of the above roles. All roles are necessary, thus all roles are rewarded with newly minted Pi on a daily basis as long as they participated and contributed during that given day. In the loose definition of a miner, being a user who receives newly minted currency as a reward for contributions, all 4 roles are considered to be Pi miners. We define mining more broadly than its traditional meaning equated to executing proof of work consensus algorithm as in Bitcoin or Ethereum. First of all, we need to emphasize that Pi node software has not been released yet. So this section is offered more as an architectural design and as a request to solicit comments from the technical community. This software will be fully open source, and it will also heavily depend on Stellar Core, which is also open source software. Now, I will say the node has been released at the time of me recording this video, but I will still go into the nodes, and then we'll wrap up at the Pi economic model, and then we'll pick up on the next video. Nodes. For readability, we define as correctly connected node to be what the SCP paper refers to as the Intact node. Also, for readability, we define as the main Pi network to be the set of all intact nodes of the Pi network. The main task of each node is to be configured to be correctly connected to the Pi network. Intuitively, a node being incorrectly connected to the main network is similarly to a Bitcoin node not being connected to the main Bitcoin network. In SCP's terms, for a node to get correctly connected means that this node must choose a quorum slice such that all resulting quorums that include this node intersect with the existing network's quorum. More precisely, a node is correctly connected to a main network in already correctly connected nodes. If the resulting system n plus 1 nodes enjoys quorum intersection, in other words, n enjoys quorum intersection if any two of its quorums share a node for all quorums. The main contribution of Pi over the existing stellar consensus deployment is that it introduces the concept of a trust graph provided by the Pi contributors as information that can be used by the Pi nodes when they are setting up their configurations to connect the main Pi network. When picking their quorum slices, these nodes must take into consideration that the first graph provided by the contributors, including their own security circles. To assist in this decision, we intend to provide auxiliary graph of analysis software to assist users running nodes to make as informed decisions as possible. This software's daily output would include a ranked list of nodes ordered by their distance from the current node in the trust graph, a ranked list of nodes based on page rank analysis of nodes in the trust graph, a list of nodes reported by the community as faulty in any way, a list of new nodes seeking to join the network, a list of most recent articles from the web on the keyword misbehaving Pi nodes, and other related keywords. A visual representation of nodes comprising the Pi network similar to what is shown in Stellar Beat Quorum Monitor source code. A Quorum Explorer similar to quorumexplorer.com source code, a simulation tool like the one in Stellar Beat Quorum Monitor that shows the expected resulting impacts to this node's connectivity to the Pi network when the current node's configuration changes. An interesting research problem for future work is to develop algorithms that can take into consideration that trust graph and suggested each node an optimal configuration or even set the configuration automatically on the first deployment of the Pi network. While users running nodes can update their node configuration at any time, they will be prompted to confirm their configurations daily and asked to update them if they see fit. Mobile app users. When a pioneer needs to confirm that a given transaction has been executed, that they have received Pi, they open the mobile app. At that point, the mobile app connects to one or more nodes to inquire if the transaction has been recorded on the ledger and also to get the most recent block number and hash value of that block. If that pioneer is also running a node, to the mobile app connects to that pioneer's own node. If the pioneer is not running a node, then the app connects to the multiple nodes. And to cross-check this information, pioneers will have the ability to select which nodes they want their apps to connect to. But to make it simple for most users, the app should have a reasonable default set of nodes, e.g. a number of nodes closest to the user based on the trust graph, along with a random selection of nodes high in page rank. We ask for your feedback on how the default set of nodes for mobile pioneers should be selected. Mining rewards. So basically how you're rewarded for mining. And I'm going to try to blow through this as quick as possible so we can make this video shorter and get into the other ones. A beautiful property of the SCP algorithm is that it is more generic than a blockchain. It coordinates consensus across distributed system of nodes. This means that the same core algorithm is not only used every few seconds to record new transactions and new blocks, but also it can be used to periodically run more complex computations. For example, once a week, the Stellar Network is using it to compute inflation on the Stellar Network and allocate the newly minted tokens proportionally to all Stellar coin holders. Stellar's coins is called lumens. In a similar manner, the Pi network employs SCP once a day to compute the network-wide new Pi distribution across all Pi miners, pioneers, contributors, ambassadors, as well as nodes. who actively participated in any given day. In other words, pi mining rewards are computed only once daily and not on every block of the blockchain. For comparison, Bitcoin allocates mining rewards on every block, and it gives all the rewards to the miner who was lucky enough to be able to solve a computational intensive randomized task. This reward in Bitcoin, currently 12.5 Bitcoin, 40K, as we stated, it's changed since then, is given to only one miner every 10 minutes. This makes it extremely likely or unlikely for any given miner to ever get rewards. As a solution to that, Bitcoin miners are getting organized and centralized mining pools, which all contribute processing power, increasing the likelihood of getting rewards, eventually sharing proportionally those rewards. Mining pools are not only points of centralization, but also their operators get cuts, reducing the amount going to the individual miners. In Pi, there is no need for mining pools, since once a day, everyone who contributed get a meritocratic distribution of new Pi. Transaction fees. Similar to Bitcoin, transaction fees are optional in the Pi network. Each block has a certain limit of how many transactions can be included in it. When there is no backing of transactions tend to be free. But if there are more transaction nodes, order them by fee, with highest fee transactions at the top, and pick only the top transactions to be included in the produced block. This makes it an open market. Implementation fees are proportionally split among nodes once a day. On every block, the fee of each transaction is transferred into a temporary wallet from where, in the end of the day, it is distributed to the active miners of the day. This wallet has an unknown private key. Transactions in and out of that wallet are forced by protocol itself under the consensus of all nodes. In the same way, the consensus also mints new Pi every day. Limitations of future work. SCP has been extensively tested for several years as a part of the Stellar network, which at the time of this writing is the 9th largest cryptocurrency in the world. This gives us a quite large degree of confidence in it. One ambition of the Pi project is to scale the number of nodes in the Pi network to be larger than the number of nodes in the Stellar network to allow more everyday users to participate in the core consensus algorithm. Increasing the number of nodes, while increasing the number of nodes will inevitably increase the number of network messages that must be exchanged between them. Even though these messages are much smaller than an image or a YouTube video, and the internet today can reliably transfer videos quickly, the number of messages necessary increases with the number of participating nodes, which can become bottleneck to the speed of reaching consensus. This will ultimately slow down the rate at which new blocks and new transactions are recorded in the network. Thankfully, Stellar is currently much faster than Bitcoin at the moment. At the moment, Stellar is calibrated to produce a new block every 3 to 5 seconds, being able to support thousands of transactions per second. By comparison, Bitcoin produces a new block every 10 minutes. Moreover, due to Bitcoin's lack in the safety guarantee, Bitcoin's blockchain in rare occasions can be overridden within the first hour. This means that a user of Bitcoin must wait about an hour before they can be sure that a transaction is considered final. SCP guarantees safety, which means after 3 to 5 seconds, one is certain about a transaction. So even with the potential scalability bottleneck, Pi expects to achieve transaction finality faster than Bitcoin and possibly slower than Stellar, and process more transactions per second than Bitcoin and possibly fewer than Stellar. Last paragraph. While scalability of SCP is still an open research problem, there are multiple promising ways one could speed things up. One possible scalability solution is the BLOX route. The BLOX route proposes blockchain distribution network, BDN, that utilizes a global network of servers optimized for network performance. While each BDN is centrally controlled by one organization, they offer a provably neutral message passing acceleration, i.e. BDNs can only serve all nodes fairly without discrimination as messages are encrypted. This means the BDN does not know where messages come from, where they go, or what is inside. This way, Pi nodes can have two message passing routes, a fast one through BDN, which is expected to be reliable most of the time, and its original peer-to-peer message passing interface that is fully decentralized and reliable, but is slower. The intuition of this idea is vaguely similar to caching. The cache is a place where a computer can access data very quickly, speeding the average computation, but it is not guaranteed to always have every needed piece of information. When the cache misses, the computer is slowed down, but nothing catastrophic happens. Another solution can be using a secure acknowledgement of multicast messages in open peer-to-peer networks to speed up message propagation among peers. And that concludes part 2 of 6 with the Pi Network Pi white paper.